Section 5.2, Normal Distributions, Finding Probabilities. In our last section, we were talking about finding some specific z-scores and then seeing the percentage under the curve. Under here, I want to cover specific practices with this and give several examples, looking at both sides of the z-table. And as I say on the top here, if we know the mean, which is mu, that's the letter cursive letter u, standard deviation, small sigma, and that standard deviation, and that is the normal distribution for it, in other words, a bell curve, we can determine the probability of any given value. Now, here's an example here. It is found that the average college student works 22 hours a week with a standard deviation of 9 hours. Given that the distribution is normal, that means it's a bell curve, what percent of students work less than 4 hours a week? I've got a curve here on the bottom, and you can see the mean is 22 hours. One deviation is 9 hours. So plus 1 is 22 plus 9, 31 hours, plus 2 deviations would be 22 plus 9, which is 22 plus 18 is 40 hours. Same thing in the negative direction. Minus 1 deviation is 22 minus 9, which is 13 hours. And then minus 2 deviations is 22 minus 9, which is 22 minus 18, which is 4 hours. So remember, our z-score is found by finding whatever value we're looking for minus the mean all over the standard deviation. We want to know what percentage of students work less than 4 hours a week. So my x is my 4 hours minus my mean, which is 22, divided by 9, which is my standard deviation. 4 minus 22 is minus 18. Minus 18 over 9 is minus 2. So my z-score is minus 2. And if I go here to my table, I've got the z-score is negative 3.4 to 0. And look at negative 2.0. And here is negative 2.0 right here. And I'm using my little arrows to show you exactly where it's at. It is 0.0228 or 2.28%. So in other words, we have 0.228 right here. That's what percentage is under the curve right here. And that means 2.28% or 0.0228% of all college students work less than 4 hours a week. And that's minus 2 deviations, exactly minus 2, which is 2.0. Now here's another one. The average speed of vehicles on a stretch of highway is 67 miles per hour with a standard deviation of 3.5 miles per hour. A vehicle is selected at random. What's the probability that they're violating the speed at 70 miles per hour? Assume the speed is normally distributed. So we know it's normal distribution. It tells us that in the last sentence, which means it's a bell curve. My mean, my mu, is 67, and I made a curve at the bottom, shows the mean 67 miles an hour. And then plus 1 deviation would be 67 plus 3.5, which is 70.5, plus 2 is 70.5 plus 3.5, or 67 plus 3.5 plus 3.5, which is 74. Then go in the same direction to get minus 1 deviation of 63.5, minus 2 deviation of 60.0. But we know exactly what is the probability of someone going the speed limit, violating the speed limit at 70 miles an hour. So the average speed is 67. We want to know what percent of people are going 70 miles per hour. So I use my z-score formula. My x is my 70. It's what I'm looking for, minus my mu, which is 67 divided by 3.5. 70 minus 67 is 3 over 3.5. I use my calculator to find out what is 0.8571. That's approximately 0.86 when I round that. So 3 over 3.5 is 0.86. Now I'm going to look up 0.86 because that's my z-score on the table. And it's positive, so I'm using the positive side. And when I look it up here, I'm going to look at 0.8. There's 0.8 here. And I'm going to go across to the 6.06. So 0.86 is right here. 0.8051. So the space under here is right here from very beginning to that point, 0.86, is 8051%. I mean 0.8051 or 80.51%. But we want to know what percent is greater than that. So this is from 70 miles an hour or less is 80.51. But the remaining part here is on this side, from here to this side of the curve. And remember, everything on the curve is 100% or 1. So all I would do is I would take 1 minus 0.8051, and what's remaining is 0.1949 or 19.49%. So 80.51% is from the very beginning here up to this 0.86 where I got this red line. And then beyond that, from here to the very end is 100%. And I subtract 100% from 80.51%, I get 19.49%. So 19.49% of cars I'm selected are probably violating the 70 mile an hour speed limit. Now here is one looking at two different areas. It's like what we did in our last section where you find each individual one and subtract one from the other. The average shopper supermarket spends 43 minutes shopping on average with a standard deviation of 12 minutes in the store. As you see at the bottom here, I've got my graph showing the 43 minutes, which is the mean, and then plus or minus 1, 2, 3 deviations, each deviation being 12. So plus 1 would be 43, plus 12 is 55, minus 1 would be 43, minus 12, which is 31, and so on and so forth. This is more for visuals, so you understand what percent is under the curve. My mu is 43, my sigma is 12, my standard deviation is 12. And we want to know what percent spend between 22 and 37 minutes. So we have to find both for 22 minutes and for 37 minutes, the standard deviations. For 22 minutes, it'd be 22 minus 43, my 22 minus my mu over my sigma, which is 12. 22 minus 43 is minus 21 over 12. That is negative 1.75. And then we want to know at the upper end, 37 minutes. 37 minus 43 is minus 6 over 12. And that is negative 0.5. So what I'm looking at here, it's between negative 0.175 and negative 0.5. And here is negative 1.75 right here. I'm pointing it down here. And negative 0.5 is right here. So we want to know the space between here and here. And again, this space shows me from negative points from the very beginning to 0.75. And then this space shows from the very beginning to negative 0.5. So I want to subtract negative 1.75 from negative 0.5, and I'll get how many shot between 22 and 37 minutes. So my z-score at 22 minutes is negative 1.75. Here is negative 1.7. And then 1.75 is 0.0401, which is what I got right here. And then negative 0.5, my second one is negative 0.50. And that is right here, negative 0.50. And there's negative 0.50 right there, 0.3085. So the difference between, remember, from here to all the way to there is 38.5%. From the very beginning all the way to this one, my negative 1.75, is 4.01. But I want to find this space between these two right here. So simply 38.05 minus the 4.01, I get 34.04%. So 34.04% are shopping between 22 and 37 minutes when we have a mean of 43 minutes and a standard deviation of 12 minutes. Then I asked us, well, how many shoppers is that between 22 and 37 minutes? We had 200 shoppers in the store. I simply multiply 200 shoppers, which is my total population, times 0.3404, that number we found, I get 68.8, so it'd be about 68 shoppers. Now here's a similar one, but actually the same data with 12-minute standard deviation, mu, which is the mean at 43 minutes, but it wants to know how many shoppers are more than 37 minutes. So originally, if there were 37, if there were more than 200 shoppers, how many would be 37 minutes? And I got at 37 minutes, it'd be 37 minus 43, which is negative 0.5. We already figured that one out already from the previous page. And that's where we got this right here. And if you forgot, here is negative 0.50, which is 30.85 right there. Now, it wants to know how many are shopping more than 37 minutes. And what we do here is we go from here. Remember, this is 30.085% from here to here. And everything from here to here is 100%. So I'm simply going to subtract 100, which is my 1, minus 30.85, and I get 69.15%. And if we had 200 shoppers as before, 200 times 69.15% is 138.3 shoppers. So about 138 to 139 shoppers shop more than 37 minutes.